Good evening to one and all. My name is T.srinivasarao, chemistry faculty, presently associated with the Sabrish Group. Now we can discuss about small topic synthesis of paracetamol. Paracetamol is a drug material. Before going to discuss about this topic, we have to know the definition of drug. Drug is a substance, it gives the positive effects as well as the negative effects on human body. It gives the positive effects, that is they are calling as a medicine. It gives the negative effects, that is they are calling as a poison. This is according to medicinal chemistry. Suppose if you are taking alcohol according to doctor prescription, that is the medicine. Suppose we are taking excess of the alcohol, it acts as a poison, consequences death of the humans. Paracetamol is a drug material. It is a antipyretic drug. It is used for the controlling of the fever. So it is also used for the controlling of the pains. For the synthesis of paracetamol, we have to use mainly three types of raw materials. One is para-aminophenol. Second one is acetic anhydride. Third one is concentrated H2SO4. So these three raw materials we are using for the synthesis of paracetamol. First one is para-aminophenol. This is the benzene ring. In benzene ring, OH group is the substituent, that is the phenol. OH group HN position is also, next position is meta, opposite position is para. So this is the meta, this is the ortho. OH group opposite position, that is the para group, para position. So in para position, NH2 group is present. This is we are calling as a para-aminophenol. For synthesis of para-aminophenol, we have to take the starting material phenol. So for the phenol, we have to take the nitration treated with nitration mixer, that is concentrated HNO3 plus H2SO4 1:2 ratio. So from this, NO2 group is releasing takes place. This NO2 group is a substituent on that, gives the two types of products. One is OH group, orthonitrophenol. Second one is para-nitrophenol. So this is the mixture of compound is forming takes place. From this mixture, we have to separate the para-nitrophenol by steam distillation method. So here in these two compounds, orthonitrophenol consisting of intermolecular hydrogen bonding, para-nitrophenol consisting of intramolecular hydrogen bonding. Due to this reason, orthonitrophenol is a more volatile. It is easily goes evaporation. So we will get that para-nitrophenol. After getting a para-nitrophenol, we have to do the reduction. This is the para-nitrophenol. We have to do the reduction. What is reduction? Addition of hydrogen, removing of oxygen is we are calling as a reduction according to organic chemistry. So in reduction process, O2 group is removed by hydrogen group. So for reduction reagent is sodium borohydrate. So here This is OH. This is NH2. So in this way we are preparing the para-aminophenol. This is one of the raw material for the synthesis of the paracetamol. Second raw material is acetic anhydride. Acetic anhydride is formed by removing of water molecule from two acetic acid molecules. Acetic acid formula is CH3COOH plus CH3COOH. Removing of the water gives that acetic anhydride. In this synthesis, acetic anhydride acts as a acylating reagent. This is acetic anhydride. Middle of oxygen group is present. Oxygen is consisting of lone pair of electrons. Third one is concentrated H2SO4. Here, concentrated H2SO4 acts as a catalyst. Catalyst is defined as the substance does not participate in a chemical reaction. It increases or decreases the rate of reaction by changing of reaction path. It increases the rate of reaction, that is we are calling as a positive catalyst. It decreases the rate of reaction, that is we are calling as a negative catalyst. Here H2SO4 acts as a positive catalyst. Synthesis of paracetamol. Step 1. H2SO4 undergoes dissociation, releasing H plus ions and HSO4 minus ions. This H plus ions initiate the chemical reaction. Step 2. We are taking acetic anhydride CH3 C double bond O C double bond O CH3. This is the oxygen plus hydrogen is H plus an electron deficient from H2SO4. So here middle oxygen consisting of lone pair of electrons. It donates the lone pair of electrons to H plus for the bond formation. Use that CH3 C double bond O C double bond O CH3. Oxygen is bonded with hydrogen. Electron deficiency arises on oxygen. To overcome the electron deficiency, the bond electron present between carbon and oxygen shifting towards the oxygen. Here, resulting acyl group is forming takes place. This is the acyl group. So, in addition to acyl group, acetic acid is also formed. This is the acetic acid. Once again, I am repeating in step 2, we have to take the acetic anhydride, treat it with H plus, which is released in the first step. Oxygen consisting of lone pair of electrons, it donates the lone pair of electrons to H plus for the bond formation. Resulting electron deficiency arises on the oxygen. To overcome the electron deficiency, the bond electron present between carbon and oxygen shifted towards the oxygen. So in this case, acyl group is forming CH3 C double bond O plus acyl. This is acyl group, and CH3COOH. This is the acetic acid. Step 3. Para-aminophenol. For convenient purpose, we are taking like this. This is the NH2. This is the OH. Is treated with acyl group C double bond O CH3. Carbon is electron deficient. Here nitrogen consisting of lone pair of electrons. Nitrogen donates the lone pair of electrons to electron deficient carbon for the bond formation. So like this. N, hydrogen, hydrogen. So here C double bond O CH3. Electron deficiency arises on the nitrogen due to this positive charge forming takes place. Here this is the OH group. So here electron deficiency on the nitrogen due to this H is releasing as a H plus like this. So product is NH C double bond O CH3. Here OH. So this is paracetamol. Paracetamol. Finally, here resulting what happens? Acetylation of the para-aminophenol. This is the compound name is the paracetamol. Paracetamol acts as a antipyretic drug. It is used for the controlling of the fever and also used for the controlling of the pains. It is a very important drug. In generally, most humans are using this drug in daily life. Thank you, one and all.